Welcome to the third day of Summer General Physics. On this third day, we'll be looking at acceleration and considering a particular kind of acceleration called freefall. We will also be looking at two-dimensional motions and a specific type of two-dimensional motion involving projectiles. In this first video, we will be looking at freefall. But before we get to freefall, here's a question that pertains to what we learned in yesterday's series of videos. So this question asks, car A, which is traveling from New York to Miami, has a speed of 25 meters per second. Car B, which is traveling from New York to Chicago, also has a speed of 25 meters per second. Are their velocities equal? Yes or no? So pause the video here and think about your response to this question. So now that you've had a chance to think about this question, what should the answer be? Are the velocities equal? Well, we know that the speeds are equal. They're both 25 meters per second, and that would be the reading on both of the car's speedometers. However, the directions of motion are different. So if the car A is going from New York to Miami, it would be traveling mostly south. Car B would be traveling mostly west. So the directions of motion are different. And we remember that velocity is a vector which combines speed with direction. So since the directions are different, the velocities would be different as well. So these two velocities would not be equal. So we're going to be taking a look at freefall. And what is freefall? Freefall is the motion experienced by objects that are moving under the influence of gravity only. So only gravity is affecting their motion. That means that these objects are not being touched or pushed. They're not under the influence of other forces. So for example, you wouldn't have a magnet influencing the motion. And we're also neglecting air resistance. So freefall is a good model for objects that are not terribly fluffy. A feather or a piece of paper that you release from your hand experiences a lot of air resistance because it has a big surface and it has a small amount of weight. But a ball that you drop doesn't experience very much air resistance as long as it's not falling terribly fast. So freefall would be a pretty good model for that ball's motion. So if an object is experiencing freefall, its acceleration is constant as long as the object is falling near the Earth's surface. The acceleration of an object in freefall is always 9.8 meters per second squared in the downward direction. And this principle was investigated by Galileo. So there's an old story about Galileo going to the top of the Leaning Tower of Pisa and dropping weights off the top of that tower to demonstrate that different weights, even if they had different masses, even if one weight was heavier than the other, that they would fall at the same rate and hit the ground at the same time. Now, we're not sure if this story is actually true. We're not sure if Galileo actually did that. But we do know, according to his notebooks, that he was very fond of rolling objects down inclined planes. And in that way, he could water down the effects of gravity. The objects would move more slowly, and it was easier to keep track of their motion with the timing devices that he had access to. So we do know that Galileo investigated the motion of rolling objects. And he found that if you have objects that are the same size, even if they have different masses, they will roll down an inclined plane at the same rate, much like a falling object will fall at the same rate regardless of its mass, as long as air resistance is not important. So we can see this principle in action by looking at astronauts on the surface of the moon. The moon has no atmosphere, and so any object will not experience air resistance at all, which means that you could take a feather and a hammer and drop them on the surface of the moon, and they would fall at the same rate and hit the ground at the same time. So the next video that you'll see posted is a link to a movie which shows the Apollo astronauts actually carrying out this experiment. So after watching the Apollo astronauts, in the next video, we will continue to look at freefall.